Today we bring in some addition and subtraction. Now, if you had something, oh, I don't know, well, let's just say I was making something up, like 4x minus 9y plus 2x minus z. Would you be able to combine all these with addition and subtraction? No, but what you could combine is the 4x plus 2x. That will give you 6x, but there are no other y's and there are no other z's, so you would just leave this. There's nothing further you could do. Same thing with radicals. You can add and subtract them if they have the same radical. If you look at example 1, it's root 2 plus 3 root 2. Now, root 2 is like 1 root 2. So this is like 1x plus 3x. Now, if you had 1x plus 3x, that's just 4x. You add the numbers in front, and you didn't change the x. You don't change it if you're adding or subtracting. So here, 1 plus 3 is 4, and we keep it as root 2. You're going to be tempted to add that and make it root 4. You only change radicals if you're multiplying or dividing. Adding and subtracting, you do not change them. So 4 root 2. This one, they're both root 5. So we can combine them. Negative 3 minus 4 is negative 7, and you keep the root 5. Isn't that cute? If they're the same radical, you can add or subtract them. You look at example 2, 7 root 3 minus root 12, they're not the same. So we can't do anything, time to just move on. What's that? Did you say there's still a perfect square in 12? Oh, too much. You're too much. Yeah, you gotta break down all the perfect squares. So 12 is 4 times 3. The square root of 4 is 2. So this would be 7 root 3 minus 2 root 3. OMG, now they're both root 3s. 7 root 3 minus 2 root 3. 7 minus 2 is 5. And we keep the root 3, baby. This one, different radicals, but there's a perfect square in 20. That's 4 times 5. So we're going to make that 3 root 4 root 5. There are no perfect squares in 2 root 5, so you could write it, but I'm going to finish this first part up before I bring down the 2 root 5. Square root of 4 is 2. So this is 3 times 2 root 5. 3 times 2 is 6. So that first term, that 3 root 20, simplifies to 6 root 5 plus 2 root 5. 6 root 5 plus 2 root 5, 8 root 5. Yes. Yeah. Yeah, we did it. All right, cool. What else we got? Oh, multiplying? Oh my goodness. Distributing. Root 3 times root 6. You can multiply anything with anything. They're both in radicals, so you keep it under the radical. 3 times 6 is 18. Cool. When we do something like root 3 times a regular 7, you just mash them up next to each other. That'd be 7 root 3. Now you do need to break it down with perfect squares, so 18 still has a perfect square in it. That's 9 times 2. Root 3 doesn't have anything, so we'll leave that for now. Root 9, square root of 9 is 3, so we have 3 root 2. Now I'll bring this plus 7 root 3. Do they have the same number in the radical? No. So we can't go any further. So as wild as this seems, that will be our final answer. And it's all right. Let's try this one out. Root 2x times root 6x. They're both under radicals. 2 times 6 is 12. X times x is x squared. Cool. There's probably some perfect squares in there that we'll need to handle later. Here we have a positive times negative. I know that's negative. Root 2x times 11 is just 11 root 2x. There are no perfect squares in 2x. So we're not going to do anything with this for now. But we do have to break down this 12x squared. A perfect square in 12 is 4. It's 4 times 3. And x squared is a perfect square, so we could put it with the 4. The square root of 4x squared is 2x. 2x root 3, that's all we can do to that one, minus 11 root 2x. Do they have the exact same thing in the radical? No. So we can't add or subtract them if there's any difference in the radicals. We got one more. We're going to have to FOIL out some stuff. Ooh! Here we go. Oh my goodness. All right, first, outer, inner, last. 2 root 6 times root 6. If it helps, you can make that 1 root 6. Remember, we can multiply the stuff, the whole numbers with whole numbers, radicals with radicals. So when we do 2 root 6 times 1 root 6, we could do 2 times 1, that's 2. Root 6 times root 6 is root 36. And yeah, that's a perfect square, but we'll handle that later. Let's do the other stuff. 2 root 6 times negative 5 root 3. Well, 2 times negative 5 is negative 10. Root 6 times root 3 is root 18. There might be some perfect squares to mess with there. Now we got to do the inside. 3 root 3 times 1 root 6. 3 times 1 is 3. Root 3 times root 6 is root 18. Great. Last one. 3 times negative 5 is negative 15. Root 3 times root 3 is root 9. I would recommend breaking down all the perfect squares first. You'll see we could combine these right now if we wanted because they're both root 18s. It's not going to be a huge time saver. I would say always just break down, handle all your perfect squares, and then combine what you can at the end. Look, 36 is 6, right? So this is just 2 times 6, which is 12. Cool, that's our first term. You look at the next one, root 18 could be 9 times 2. So the square root of 9 is 3. So we have negative 10 times 3 root 2, that's negative 30 root 2. That's all we can do to that one. We look at the next term. It's 18 again, which we know 9 goes in there. The square root of 9 is 3, so it's 3 times 3 root 2. 3 times 3 is 9, so this comes out to 9 root 2. Last one. 9 is a perfect square. It's just 3, so it's negative 15 times 3, which is negative 45. Whew. We've taken down all the perfect squares. Last thing to do is combine our like terms. I could do 12 minus 45, that's negative 33. And these are both root 2's. Negative 30 root 2 plus 9 root 2. Negative 30 plus 9 is negative 21 root 2. Now, you can't combine those. When you have whole numbers and also some radical expressions, put the radical expressions at the end. That's proper form, standard form, if you will. If there's all kinds of radicals that you can't combine, it really doesn't matter which one you put first. There's one for you to try here. It's written as square root of 7 plus 4 squared. Remember, that means the square root of 7 plus 4 times the square root of 7 plus 4. I'd recommend just write it out like that and then FOIL it. There was a shortcut, but it really doesn't save you time, so you'll make less mistakes, IMO, if you do it this way. Pause it, try it out. This is our last example. Root 7 times root 7 is root 49. Root 7 times 4, 4 root 7. Inside, we have another 4 root 7. And then last, 4 times 4 is 16. Square root of 49 is 7. Can't really do much else. We could do the 4 root 7 plus 4 root 7 is 8 root 7. And then the last thing we could do is combine our 7 plus 16 is 23 plus 8 root 7. Guys, we did it. It's done. Look at us, we're all so smart today.